This course will guide you through the basics of N-topology to help get you started on your own journey of exploration of the software. In this course, you will build your understanding of implicit modeling, which influences how you will interact with the software in order to create workflows and designs. You'll learn to efficiently use blocks and manage your notebook, and become comfortable with the controls and basic operations in N-topology. As you're getting to know the software, there are two important resources available for your use. Both are accessible from within the software by going to the upper right-hand corner and clicking on the question mark button. The documentation, which comes with the software and is installed on your local drive, contains information about the different features and functionalities offered in N-topology. Our support site, called the Help Center, also accessible by going to support.ntopology.com, contains helpful articles where you can find answers to some of your questions as you are learning the software. N-topology is meant to be used to complement and work with your current engineering tools, so we don't typically start from zero. Instead, we import into N-topology things like CAD or mesh files that we have already designed, or even in combination with other engineering data and test results, for example from structural analysis and optimization, or CFD data. We then use these inputs as references to create complex geometry and designs that are difficult or impossible to do elsewhere. We can export what we've done in N-topology into files or data for the next design iteration, for manufacturing, or as files to be further analyzed or optimized in external analysis software and solvers depending on your specific applications. Essentially, what we do in N-topology is not creating a specific part, we are building a process that can work on any part. This means that whatever we build can easily be reused and automated. This is possible because of the way that N-topology represents geometry. The legacy method of describing geometry is through boundary representation, or BREP for short, where faces are created and joined together by edges to separate the inside and outside of a solid part. N-topology works quite differently. It describes the same geometry or volume using a mathematical equation. This is a much more lightweight way of handling geometry data, and because we're only working with equations, we're able to very quickly generate complex structures without adding to the file size. N-topology stores these volume-defining equations behind the scenes, and with given input parameters, it computes these equations and then renders out a visual representation on the screen. This visual representation is called the implicit body, which is N-topology's native format. There is an implicit field associated with every implicit body, which allows us to visualize these behind-the-scene equations. In the next lesson, you'll learn more about these implicit geometries and implicit fields. The geometry. N-topology's approach to modeling geometry is based on the implicit field technology, which makes it possible to reliably perform modeling operations without ever breaking the geometry, and enables increased design complexity and automation without adding much to the file size. To take advantage of this powerful technology, we need to understand the world of implicits and learn to work with them. Since implicit geometries are very closely tied with fields, let's start by understanding what a field is. If we think about weather information, such as temperature, humidity, and wind speed, these are continuous and everywhere. And if we probe the values at different locations, we can sample the temperature or humidity at those points. This is a field. Similarly, fields can also represent different types of data, such as stress, velocity, or distance. All this can be used alone or combined together to enhance our implicit geometry for optimal performance. What drives the geometry in n-topology is the distance field, where at every point in all direction in the infinite 3D space, there is a distance value that describes how far away that point is from the boundary of the geometry. These values are the outputs of the mathematical equation that describes that geometry. And we use the term implicit to mean that the values of this distance field is negative where it is inside a solid body, and positive where it is outside of this body. So an implicit field is defined as a scalar field that describes a shape by the non-positive value of a field, and an implicit body is simply defined as a three-dimensional geometry represented by an implicit field. There's a tool inside the software for visualizing and probing the values of the field of every implicit body. This is called the field viewer. It allows us to see the section view of the field at a plane, like a window that lets us look into what is continuous in the 3D space. The two different color gradients distinguish the positive and the negative areas. Simple elements like planes and points have simple fields associated with them as well. For example, along the plane, the value of the field is 0. To one side of the plane, the values are entirely positive, and to the other side, the values are entirely negative. To turn on autosave feature. Let's have a quick look at the n-topology instance so that you can get familiar with its user interface and the system settings. To the right of this welcome screen, you have access to NTOP News and other resources, such as the documentation, release notes, and the Help Center. To access these resources at any time, navigate to the Help button at the top right corner, where you'll also find your account details and any available software updates. There are also a number of example files here that you can open up to see how these different parts and workflows have been created for different applications. Clicking on New File opens up a new empty instance. The ribbon at the top contains blocks that are used to perform different operations, and they are categorized into multiple tabs. The Create tab contains primitive implicit bodies, as well as curves, vectors, planes, and points. The Modeling tab has common modeling operations such as offsetting, shelling, thickening, and Boolean operations. Under lattices are blocks for creating different types of lattices. Under fields are blocks for creating and manipulating fields. The Math tab can be used to create equations and calculations for your workflow. Simulation has all blocks required to perform finite element analysis and topology optimization. Under Utilities are options for import, export, and conversions of different file types, for example, from a CAD body to a mesh. The Manufacturing tab contains blocks for slicing and exporting your part file for manufacturing. The Beta tab contains blocks that are currently being actively developed and will only appear in the ribbon if you change the settings to show beta blocks. The last 5 tabs are what we call toolkits. They contain prepackaged workflows and some other utilities specific for different applications. The notebook on the left keeps a record of your modeling operations. You will work entirely within this notebook to build your workflow and manipulate the design parameters of your parts. The viewport is where you can see the visual rendering of the geometry you've created by working in the notebook. The view cube shows the XYZ axis indication and is where you can see and change the view or perspective options, as well as create your own view and do image capture. Resolution settings are located at the bottom right corner. We recommend working in low or medium res and using high or highest res only to check your geometry. Changing the resolution only affects the loading time and the quality of the rendered image on the screen, not the actual part. The arrow to the right of the resolution settings expands and collapses a window that shows timestamps of your operations, as well as how long processes are taking to complete. If a process is in progress, the status bar on the left side would appear, By hovering over it, you can see the related block's name, the process being executed, and the percentage completion. You can access the settings from the menu bar by going to File, then Settings. Options to show beta blocks and to enable GPU acceleration are under General. You can turn off the display of individual ribbon tabs that you don't use and change the display layouts here. Changing the theme color requires a software restart, but the viewport background can be changed right away. The display grid and ruler can also be turned on and off or adjusted here. There's also the option to change the default units and to turn on autosave feature. Shortcuts. To help you get the most out of N-topology, we will introduce the controls and tools for manipulating the model view as well as useful keyboard shortcuts in our software. You can zoom in and out using the mouse scroll or by holding Control and right-click. To orbit around the center of the object, right-click and hold. To pan, click on the scroll wheel and hold, or hold Shift and right-click. You can also adjust your view using the View Cube. The View Cube is completely interactive and you can orient your views with a click on a labeled face, edge, or corner, and rotate your object either counterclockwise or clockwise by using these arrows. There are two different camera settings you can explore: orthographic, which is the default setting, and perspective. When you are in orthographic view, objects don't have depth. For example, from whichever view of angle we're in, these two tires will look to be about the same size no matter how close or far away we are from them. While you're in this view, you can use the ruler at the bottom to roughly measure any features of the part. If you're working on something like a small screw or bolt on this tire, you might experience something called the CAD goggles, where you zoom in too far and lose sense of how big things are. But with perspective view, it gives the effect that the farther away the object is, the smaller it will look, and vice versa. So it gives you a better sense of depth and helps you avoid CAD goggles. In this perspective, you can also zoom in, fly through these small holes, and work on small detailed areas of the model. There are also two different rotational styles, the turntable and tumbler. Right now we have the tumbler selected, and we can move and rotate the model to view it at an arbitrary angle. If you choose to use the turntable, the model's set axis will always remain pointing up and down on the screen, and the camera will not be able to rotate all the way around the object. Let's move on to keyboard shortcuts. Useful hotkeys and keyboard shortcuts in N-topology can be categorized based into ones that are for views, blocks, or for working with files. Let's start with the keyboard shortcuts you can use when you're manipulating your views in N-topology. You can find all your viewing tools on the menu bar at the top left under View, and their keyboard shortcuts associated with them. While working with your model, there might be times when you lose sight of your part, or while working zoomed in too far. You can reset the view by pressing Z on the keyboard to bring your part back into view at a reasonable distance. Make sure the block's visibility is toggled on when using the zoom to select it, and you can toggle the visibility of a block on and off by pressing V on the keyboard while the block is selected. To turn on the display grid, press Alt and G together on the keyboard. To do the same for the ruler that's located at the bottom, use Alt-R. To see the section cut view of a part, select the part you want to cut, press X on the keyboard, then determine your location and orient the plane. To open up the field viewer, select the block and press F on the keyboard. Toggle off the visibility of your block and you'll be able to see the field of the implicit body that you've selected. To see a precise high-resolution render of the part or to do a high-resolution image capture, use Ctrl-H. Next, we'll go over the shortcuts you can use while working with blocks. To be able to quickly search for blocks you need, use Ctrl-L as a shortcut to the search bar. When importing a part, rather than searching for an import block, you can also press Ctrl-I on the keyboard to open up your files from which you can choose what you'd like to import. To isolate the view of